Hello, everyone. My name is Yuan. I'm a postdoc at MIT. Today, I'm happy to introduce our recent work, Contrastive Audiovisual Masked Autoencoder. First, in this work, we targeted at the self-supervised learning problem. As we know, self-supervised learning does not rely on any labeled data, so we can easily scale it up with web-scale, almost unlimited video data. While there are tons of self-supervised learning framework proposed in recent years, I think nearly all of them can fall into two categories. The first category is masked data modeling or learn by prediction. So it uses the input data itself as the supervision signal. For example, here we mask a large portion of the image and audio spectrogram, and we want the model to recover them. So the problem with masked data modeling is that it can use single model information for the recovery and might not leverage the audio-visual correspondence during the learning process. The second category of self-supervised learning is contrastive learning. We use audio-visual pairedness as the supervision signal in contrastive learning. For example, we want to match the audio and visual pair during the learning process. The disadvantage of this method is it might discard modality unique information that is not used in the matching process, but this information could still be important for example, joint classification tasks. Since both self-supervised learning frameworks have their advantages and disadvantages, so a natural idea is, can we combine them together as a stronger one? That's what we propose in this paper. We call it CAV-MAE. CAV-MAE combines contrastive learning and masked data modeling and make a single model to learn joint and coordinate audiovisual representations. There are some key designs of CAV-MAE. First, we use multi-stream forward passes of the joint encoder. That means the audio and visual representations have not attend to each other before the contrastive loss. That avoids the collapse of contrastive loss. The second is, in order to improve the performance, we use modality-specific encoders and layer norm layers. The third is, in order to unify these two frameworks, we also do masking for the contrastive learning, which is not typical in previous studies. Let's look at the results. For the audiovisual joint event classification, we find that combining MAE and contrastive learning always lead to a performance improvement that is consistent across all three datasets. So the conclusion is contrastive learning and masked data modeling are complementary for this task. Another interesting finding is we find multi-model pre-training always improve the single model performance. That means even you are only interested in a single modality model, it's better to train the model in a multi-model manner. And the second experiment we did is audiovisual retrieval to evaluate the quality of coordinate representation. As we can see, without a contrastive or projective, MAE model is not able to do audiovisual retrieval at all. However, when we add MAE loss to contrastive learning, we find that the MAE loss does not hurt and in many cases improve the retrieval performance, so that we can have a single pre-training framework for both tasks. To conclude, we studied self-supervised learning in this paper, and for the first time, we showed the two major self-supervised learning framework, contrastive learning and masked data modeling, are complementary and should be combined together. As a result, our CAV-MAE model achieves SOTA performance on both audiovisual joint event classification tasks and audiovisual retrieval tasks. We also find CAV-MAE multi-model pre-training improves single model performance. We have released code and pre-trained models at this link. We have more interesting results in the paper. Please check.